Have you ever wondered how the fiery molten spectacle of a volcano comes to be? This burning question has ignited the curiosity of many, sparking a quest to uncover the enigmatic process behind volcano formation. It's a journey that takes us deep beneath the Earth's crust, through a tectonic tango of monumental proportions, leading to the awe-inspiring birth of a volcano. We'll unravel this mystery piece by piece in the coming minutes. So join us as we delve into the fascinating process of volcano formation. Our journey begins beneath the Earth's crust. Imagine peeling back the surface layer of an orange. What you see underneath is akin to the Earth's crust. This outer shell, surprisingly thin compared to the planet's overall size, is predominantly composed of two types of rock, basalt and granite. But don't be deceived by its apparent solidity. The crust is fragmented into a jigsaw puzzle of vast pieces known as tectonic plates. Beneath these plates lies the mantle, a thick layer of hot viscous rock that extends to the Earth's core. Here, under extreme temperature and pressure, a substance called magma forms. Magma, a molten rock cocktail with a dash of dissolved gases, is lighter than the surrounding solid rock, causing it to rise towards the Earth's surface. Now let's talk about these tectonic plates. They're not stationary, but rather they're constantly shifting and grinding against each other on a layer of the mantle called the asthenosphere. This movement is slow yet powerful, often only a few centimeters per year, but don't underestimate it. It's this very motion that plays a pivotal role in the formation of volcanoes. When these plates collide, pull apart or slide past each other, they create cracks or weak spots in the Earth's crust. Magma seizes the opportunity, forcing its way up through these fractures, leading to volcanic activity on the surface. Now, let's see what happens when these tectonic plates start to move. The dance of the tectonic plates is where the magic happens. Imagine the Earth's crust as a grand ballroom floor, with the tectonic plates gliding, colliding, and diverging in a seemingly endless waltz. This terrestrial tango is the key to understanding how volcanoes come to be. You see, the Earth's crust isn't one solid piece. It's a jigsaw puzzle of large slabs called tectonic plates. These plates are constantly moving, albeit at a snail's pace of a few centimeters per year. Their movement is driven by the intense heat in the Earth's core, causing a process called convection. Now, these tectonic plates don't always play nice. Sometimes they collide or pull apart from each other, creating what we call convergent and divergent boundaries, respectively. At convergent boundaries, one plate gets pushed beneath another in a process called subduction. This generates intense pressure and heat, causing the rock to melt and form magma. On the other hand, at divergent boundaries, plates move apart, creating a gap. Magma from beneath the crust seizes this opportunity, rising to fill the void. In both scenarios, this magma seeks a way out, a release from the pressure. It forces its way up, creating cracks or vents in the Earth's crust. These vents, these pathways for magma to escape, are the birthplaces of what we know as volcanoes. The magic of the tectonic tango, as it turns out, has a fiery finale. From these vents, a volcano is born. Let's dive into this fascinating process. As we've seen, our planet is a hotbed of activity beneath the surface. When the molten rock, or magma, located in the Earth's mantle, is subjected to immense pressure, it seeks an escape route. Due to its lower density, it rises upwards, pushing through the crust towards the surface of the Earth. This magma travels through pathways or vents that are created by the movement and interaction of tectonic plates. When the magma reaches the surface, it erupts as lava. This eruption can be a gentle oozing or a violent explosion, depending on the type and amount of gases trapped within the magma. These eruptions also release large amounts of ash and gases into the atmosphere, which can have significant impacts on our environment and climate. The first eruption marks the birth of a volcano, but it is not its end. Each subsequent eruption results in more lava, ash, and other volcanic material being expelled onto the Earth's surface. This material builds up around the vent, layer upon layer, solidifying and hardening over time. While the volcano might appear dormant or inactive between eruptions, there's a lot more happening beneath the surface. The magma chamber below continues to fill up, building pressure for the next eruption. With every eruption, the volcano grows taller and wider, taking on the familiar cone shape that we often associate with volcanoes. This process of growth and eruption can continue for hundreds, thousands, or even millions of years, resulting in some of the largest and most magnificent structures on our planet, from the towering peaks of the Andes to the underwater mountains of the Pacific Ring of Fire. Each volcano tells a unique story of the Earth's geological history. But remember, not all volcanoes are created equal. Some are violent and explosive, while others are more gentle and slow. Some erupt frequently, while others remain dormant for long periods. Regardless of their size, shape, or activity level, all volcanoes are a testament to the dynamic and ever-changing nature of our planet. Over time, these eruptions create the fiery mountains we recognize as volcanoes. So, how can we summarize this fascinating process? Let's start with the Earth's crust, our planet's outermost layer. Here, massive tectonic plates are constantly on the move, sliding past, pulling apart, or crashing into one another in a geological dance known as plate tectonics. Now, when an oceanic plate collides with a continental plate, it's forced downwards into the Earth's mantle, creating a subduction zone. As the oceanic plate sinks, it's subjected to intense heat and pressure, causing it to melt and form magma. This magma, being less dense than the surrounding rock, starts to rise through the crust, accumulating in a magma chamber. Over time, pressure builds up in this chamber until it's too great to contain. That's when we get an eruption. The eruption spews out lava and ash, which cool and harden on the Earth's surface, forming the distinctive cone-shaped structure we know as a volcano. And that, in short, is how a volcano is formed. Volcanoes, a spectacular display of nature's might, and a testament to the dynamic world beneath our feet. It's a world that's constantly moving, changing, and evolving, just as we are on the surface. Understanding how volcanoes are formed is not just about satisfying our curiosity, it's about appreciating our planet's incredible complexity and dynamism. These fiery mountains remind us of the immense power that lies beneath our feet and the intricate dance of tectonic plates that shape our world. It's a dance that's been going on for billions of years and will continue long after we're gone. But while we're here, we have the privilege and the responsibility to understand it. The birth of a volcano is a fascinating process, a testament to the Earth's fiery interior and the slow but relentless movement of its crust. It's a process that can take thousands, even millions of years. And yet, the result is something that can change landscapes, climates, and even history in a matter of moments. So let's keep exploring, let's keep asking questions, because the more we understand about our world, the more we can appreciate its beauty, respect its power, and protect its future. Thank you for joining us on this geological journey. If you enjoyed this video, don't forget to subscribe, like, and share. Stay curious and keep exploring.